So we can also solve real-world problems using these simple quadratic equations. So the two equations here are going to be the basis of all of the problems that we're working with. One represents distance, and then the other one represents the height after a certain time, where h0 is the object's initial height. So it essentially means height at time 0. So for both of these models, time is measured from the instant that the object begins to fall. So a negative value of t would represent a time before the object began falling. So negative values of t for time are excluded from the domain. So that means anytime you get an answer with a negative t for negative time, we have to exclude it. So if you drop a water balloon, how long does it take to fall 4 feet? So that means we're going to use that distance equation because we're talking about how far it's falling. So that means we're going to be plugging in 4 for our distance because that's how far it's falling. So for your equation is d is equal to 16t squared. So our d of t is 4 is equal to 16t squared. So from here we divide both sides by 16, take the square root of both sides, and then we can simplify this. We have root 1 over root 4, which simplifies to 1 over 2. And again, we have to reject that negative value of t, so that means the water balloon falls 4 feet in half a second. The rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at a height of 24 feet? So this time, again, we're using height because we're telling us how far above ground we are. And we want to solve this equation for the height at 24, and then we have to set our initial height as 50 feet since that's where we're starting at. So our equation should be our height 0, which is our 50, minus 16t squared equals 24 because that's when we're trying to find how long it took to get to that height. Subtract 50 from both sides to get negative 26, and divide by 16 to get 26 over 16. So in this case, we're not going to simplify yet. It's actually going to come out to a nice number for us. So we take the square root of both sides, 26 over 16. And as we've shown before, we can break this up into root 26 over root 16. Well, we should already know that root 16 is the same thing as 4. So if we reject the negative value of t, it should pass by the window at root 26 over 4 seconds, which if you plug that into a calculator, it's approximately 1.3 seconds. So if you want to explain how that model is built from the original model, it makes sense that our height at a certain time is equal to our original height, that's our h0, minus the distance fallen. So remember that d of t is at 16t squared. So that's why we're subtracting the distance from the original height, h0. So one more problem. How long does it take for the water balloon to hit the ground? Well, if it's hitting the ground, that means we're trying to find when is the height 0. Because that's when the water balloon hits the ground, it's at height 0. So we use that height equation again. Again, our initial height there is 50 minus 16t squared. This time it's equal to 0. Subtract the 50. We can divide. Take the square root. Our 50 can actually be broken down into 25 and 2, so we can break this down a little further than last time. So since we got a 25 here, that's a perfect square, which means we can pull a 5 outside. 2 has to stay under the root, and root 16 is just 4. We've already rejected the negative value of time. We're just dealing with positive time, and this will be approximately 1.8 seconds. So on the moon, the distance of an object falls in time is modeled by the function d of t equals 8/3 t squared. So suppose an astronaut on the moon drops a tool. How long does it take the tool to fall 4 feet? So that means our distance here is 4. So if we set up our equation, 8/3 t squared should be equal to 4. So we have to multiply by the reciprocal, and we're taking 4 times 3 over 8, which is equal to 12 over 8, which reduces to 3 over 2. So if we take the square root, t should be plus or minus square root of 3 over 2. Now we'll have to rationalize our denominator here, because we don't like having that root 2 in the denominator. I'm going to go ahead right now and reject that negative value. So in the numerator, I'll have root 3 times root 2, which is root 6. And my denominator would just be 2. And if you plug that into a calculator, it is approximately 1.2 seconds.